We started the class today with a simple normal model. We have a normal distribution of a random variable x, which is height. So x is height. And we're talking about the height of American males. I asked what people thought the average height might be. They said, oh, maybe a little less than 6 feet, say 71 inches. 6 feet would be 72 inches, of course. And I asked, okay, let's do this. Okay, first of all, we have a normal distribution. Now, when we have a normal distribution, the very first thing we do is draw our usual picture. And I've described this picture and drawn it for you several times. So just to indicate and show that the picture is easy enough to draw, and you can do so pretty quickly. Okay. Curve looks something like this. And whenever we do this, we label our z's. -2, -1, 0, 1, 2. And sometimes we'll go out as far as 3 or even -3. Let me go ahead and include -3. It's not a great picture. My spacing isn't all that good, but you get a reasonable indication of the normal curve. Okay? Now, that's the very first thing you do. As soon as you see you've got something that's normally distributed, you draw this picture, and it's always the same picture, same numbers for the z values. Then we relabel. So 1, we draw the picture. With the z values. 2, label the x values. Okay, well, what's x? Well, the mean is 71 inches. Where's the mean of the normal distribution? It's right in the middle. It's the point at which the normal distribution would balance. And that's going to be at 71 inches. Now, won't label the inches, but we understand that these are going to be heights in inches. Okay, now, we also have to label the x values at 1, 2, and 3 standard deviations above, 1, 2, and 3 standard deviations below the mean. So what are those labelings? You should pause and actually label this yourself. Okay, well, the standard deviation is 3 inches. That means each of these standard deviations is going to be 3 inches. We're going to have 3 inches, 3 inches, 3 inches, and over here on this side, 3 inches, 3 inches, and 3 inches, giving us heights of 74 inches, 71 and 3 is 74, 77, and 80. On the other side, 3 inches in the opposite direction. If we take 3 away from 71, we get 68. Take 3 away from that, we get 65. Take 3 away from that, and we get 62. So here are the x values. So we've labeled the normal distribution. We've sketched the normal distribution. We've divided it into 1 standard deviation increments and labeled the z scores or the z values accordingly. Then we labeled the x values using our knowledge that the mean is 71 and the standard deviation is 3, and these numbers stand for heights in inches. Okay, now Dwayne volunteered his height. Dwayne is a big, tall guy. Okay, he's 6'7". So where is Dwayne on this scale here? Well, 6'7" is 6 feet is 72 inches. 7 and 72 is 79 inches. 79 inches tall. So here's Dwayne's height right here. Okay, so here's Dwayne. Okay, so we've done a third step. We've identified the thing that we're trying to analyze, the x value that we're trying to do the statistics on. We'll see what we do with the x value in a minute. And what we want to do, of course, is we want to figure out maybe how many people out of a million are taller than Dwayne. Certainly there are some. We just had the NCAA finals, and plenty of people over 6'7" there. NBA's coming up. Lots and lots of people over 79 inches there. Okay, so we could ask, what percent of the total population is over 79 inches, is taller than Dwayne? Or we could ask, how many people is Dwayne taller than? What proportion, what percent of the people is Dwayne taller than? So that would correspond to the area to the left of Dwayne, excuse me, to the left of Dwayne's height. How many people taller? Well, the proportion of people taller would correspond to the area to the right of Dwayne's height. And we'll see how we do that. So, third step is locate the x value of interest, the x value that we're interested in. And now there's a fourth step, which is to find the z value of that x value. By that x value, that means the x value we have here. So we want to find the z value. Now, what's the z value? Well, we can see that the z value of Dwayne's height is between 2 and 3, because right here's our z table. Can we figure out more accurately what the z value is? Just where is it between 2 and 3? Well, there are 3 inches of height between 2 and 3, and Dwayne is 2 inches to the right of 77. 77 corresponds to z value of 2, 80 corresponds to z value of 3, and this 2 inches difference in height here is 2/3 of the standard deviation, which is 3 inches. So the z value would be 2 2/3. It's 2 plus 2/3, which is 2 2/3. Okay, now we're going to go to another board that has all this information on it, but it's a little more complicated, and I didn't describe the process in specific numbered steps, which you might find helpful.